Hi, I'm Dennis Wingo, and I'm the founder and Chief Technology Officer of Skycorp Incorporated. We were founded in 1998 to help bring advanced technology applications from the computer industry into space, because there is a dire need to bring all of these advanced capabilities we have down here up there. The workloads that we have in space, in some respects, may or may not be unique. A lot of them think of it as like streaming video. If we're doing remote sensing of the Earth, we're looking at the atmosphere, we're recording, infrared data, it's a streaming application. So we're going to stream the data to the SSD. Then later we will stream the data off the SSD, or we will use edge computing and artificial intelligence to process the data in space, also requiring a lot of read-write cycles. And so it's really and truly not that much different than a terrestrial application for the SSD itself. The SSD doesn't care if it's in space or not. The need for space-based compute is being driven today by many, many reasons. First of all, we have climate change that we're concerned about. We're putting more and more advanced sensors into space, entire constellations of satellites to monitor the weather, to monitor the climate, communications applications, and we're also moving outward into space all the way to the moon and beyond to Mars. All of these things are going to require advanced compute, advanced storage, and advanced applications like artificial intelligence to make all of this expenditure worthwhile. Phison plays to us a crucial role, because without storage, you're not going to get a whole lot done out there in space. And so we built a relationship with Phison to help bring these storage technologies in. It enabled us to fly a 4 terabyte drive to the space station last year. And since the service calls are exceptionally infrequent, i.e. impossible, it has to be right the first time. And that's how this relationship has really helped us be able to get it right the first time. The Phison IMAGIN Plus platform has allowed us to really do our customization for the space environment in a manner that was much less expensive and a lot faster for us to get to space. We're looking at a mission where we're going to do it in 7 months. And with conventional methods, this would take a lot longer. And what we do when we're flying a system, we start with requirements. And we brought those requirements to the Phison engineering team. And we need things like drawings that help us understand the size and the form factor and how it works, the thermal parameters. And the Phison engineering team has been exceptionally cooperative with us, allowing us to work with them to provide engineering telemetry, working with the hardware, so that we could actually monitor the performance of the SSDs in space. So it's an exceptionally effective engineering process to be able to go from what we want to do to incorporate what Phison has in a manner that allows us to do what we need to do and gives us a great product. And we couldn't do this without the support of the engineering team that we're working with there. What's exciting to us is that space and the development of space has been constrained for many years. Those constraints are falling away as inexpensive launch vehicles and more space stations and more people going to space happen. And it is inevitable that we're going to be having much larger systems, petabytes and petabytes, exabytes of storage. We're going to have AI engines. We're going to be looking at our planet in so many different ways that we can't today. And so this is what excites us every day, because we're bringing good things to the future.